Hello, students. Today we are venturing into discussing aromatic compounds. Right? Aromatic compounds are also referred to as arenes, and these mostly include benzene and benzene derivatives, but we will see there can be things outside of benzene that actually fall into this category. All right? Benzenes and substituted benzenes will be the primary focus of chapter 17 and 18 and the reactions of these molecules as well. Okay, so many aromatic compounds were actually originally isolated from fragrant oils. And this is where we get the term aromatic from because we got them from those sources. However, if you actually come into contact with aromatic compounds, very few of them actually have any scent to them. Okay, so that's just like the name is just from where we got them. Now, they are very common functional groups. In fact, 8 out of the 10 most commonly prescribed drugs of 2020 have at least one aromatic compound in them. And you can see them highlighted in these pictures right here. Okay, now the naming of arenes can get pretty complex. So we are just going to stick with the naming of simple benzene derivatives. These compounds where benzene is the body, or what we would call the parent chain, and there is a substituent or more than one substituent coming off of the ring. Okay, some examples here. Chlorobenzene. We have a benzene molecule with a chlorine attached to it. Nitrobenzene, a benzene molecule with a nitro group attached to it. And ethylbenzene, a benzene parent chain with an ethyl group attached to it. Okay, many benzene derivatives actually have common names, right? So for some of these compounds, when naming benzene derivatives that are more complex, you can actually use the common name as the parent name, all right? What I have given you here is a list of 8 monosubstituted benzenes that have common names, right? These compounds are very, very common. In fact, they're so common that we actually just continuously use their common names. So we keep this, I'm going to ask you to keep this list handy because I will be referring to these compounds frequently in these videos. And so this way you will kind of know what I'm talking about. So just keep this around. All right. Now, there can be a situation where the benzene molecule itself is actually not the parent chain, but rather a substituent, right? And this occurs in the same situation where we saw other cyclic molecules were not the parent chain. This happens when the substituent that's attached to the benzene ring is actually bigger than the 6-carbon benzene ring itself. Okay, in that situation, the substituent is the parent chain and the benzene ring is the substituent. Okay, when a benzene ring is a substituent, it is not referred to as a benzene, it's referred to as a phenyl group. So here we have an example of a 7-carbon long straight chain attached to a benzene ring. In this case, the 7-carbon straight chain has more carbons than the 6-carbon benzene ring. So that becomes the parent chain. The benzene ring becomes a substituent, and that substituent, when benzene is a substituent, is referred to as a phenyl group. So we would call this molecule 1-phenylheptane, right? Now, in very complex molecules where you have a lot of different benzene rings, usually they are actually just not drawn out, right? They're actually usually just abbreviated either with the letters PH or with a psi type symbol rather than having to draw them all out. You will see that in organic chemistry too. So be aware of that. When you see a little P, a large P with a little H drawn next to it, that is the shorthand for a phenyl group. Okay, so We've looked at some benzene rings that have one substituent that have common names. It's also very easy to name a benzene ring with one substituent. What if you have more than one? Okay. When you have a benzene ring with more than one substituent, the orientation, meaning the distance between the two groups, is referred to a little differently than we are used to, right? Instead of using numbers, we use the terms ortho, meta, and para to define the distance between the two groups on a benzene ring. All right, so let's look at 3 examples here. Xylene is the common name for a benzene ring that has 2 methyl substituents. But when I say xylene, the word itself doesn't tell me where those methyl groups are. Are they on neighboring carbons? Are they 1 carbon apart, 2 carbons apart? Okay, so to describe the orientation of these 2 groups to each other, we use these terms ortho, meta, and para. If the 2 groups on a benzene ring are in the 1 and 2 positions on a carbon, meaning they're on carbons that are right next to each other, we say these 2 groups are ortho to each other. If the groups are on the 1 and 3 position, we say that they are meta to each other. Okay, and then finally, if the groups are on the 1 and 4 position of the benzene ring, they are para to each other. All right, it is imperative that you know and understand these words of ortho, meta, and para, because they are going to be used exclusively in the next chapter over numbering. Okay, so let's do a little example here. In the first example of my molecule, are my chlorine atoms ortho, meta, or para to each other? Okay, well, I'm going to go ahead and assign the number 1 to either one, and it doesn't matter, of my substituents. Okay, and then I'm going to count, taking the shortest path possible to the next substituent. Okay, here I find that the next substituent is on the 3 position. Okay, there's 1 carbon in between them. So these 2 groups are what we would call meta to each other. So now let's name a couple of these molecules, okay? Using the commons names I showed you on slide 4 and the ortho, meta, or para system, okay? The molecule in black shown here is going to be our parent chain, and then the red part is our substituent, right? So let's look at our first molecule, and feel free to use that little chart I gave you on slide 4, okay? The parent chain would be benzaldehyde. Right? The substituent is chloro group, and it's in the para position. So we would call this molecule para-chlorobenzaldehyde. Right? The second one, going back to our chart, the parent chain is toluene. Okay? The substituent is a bromo group, and it's in the meta position. This name, meta-bromo-toluene. Okay? And last, we have anisole for a parent chain. Okay, a nitro group is the substituent, and it's in the ortho position. So we would call this ortho-nitroanisole.